Dear students, we are solving the IB Math A HL past paper questions, and currently we are solving the IB Math A HL May 2021 paper 2 time zone 2 past paper. And today we will be solving the question number 9 of this paper. So without any further delay, let us start with our today's session, and you will be getting the links to all the previously solved questions of this paper and of the other papers in the description area in form of playlists. So question number 9. Maximum mark is 8 and it is containing 3 subparts. Subpart A, write down the first 3 terms of the binomial expansion of 1 plus t whole raised to the power of negative 1 in ascending powers of t, and it contains just 1 mark. And this is the binomial expansion when n is a rational number. In case you have forgotten, this is an infinite series. Over here, t is equal to x or x equal to t and n is equal to negative 1. So let us answer the subpart A first of all. 1 plus t raised to the power of negative 1 should be equal to the first term is 1 plus n times x. N is negative 1, so it is negative 1 and x is t, so it is t plus n times n minus 1. N is negative 1, so it is negative 1. N minus 1, minus 1, minus 1 is minus 2. Over factorial 2 and x square, so it will be t square. And we are required to give the first 3 terms, so we have given the first 3 terms and they are indeed in ascending powers of t. So now we have to simplify this a little. It is 1 and this one will be minus t, and minus 1 times minus 2 is plus 2 in the numerator, and 2 factorial is 2. So 2 over 2 is 1 and it will be plus t square. Okay. So we have completed solving subpart A, and we move on to subpart B. By using the Maclaurin series of cos x and from the result from part A, the Maclaurin series of cos x is this one. It is also another infinite series. And the result from part A. Part A was 1 plus t to the power of negative 1. This is the part A expression, the expansion that we have written, the first 3 terms of the expansion. Show that the Maclaurin series for secant of x up to and including the term in x to the power of 4. Okay. X to the power of 4 is 1 plus x squared over 2 plus 5x to the power of 4 over 24. Fine. And it is containing 4 marks. Using the Maclaurin series of cos x, so this is x to the power of 4. So we are having only we'll be taking most probably the first 3 terms. Most probably I'm saying because it is not the cos x that we have to write. It is the secant of x, which is 1 over cos x. So let us write that first of all. Okay. So secant of x is equal to 1 over cos x. Okay. And we know the expansion for cos x, that is not a problem, but the problem is that we have to use the result from part A. The part A is dealing with the binomial expansion, so there should be 2 terms, but cos x is a single term. And not only are we having 2 terms over here in this binomial expression, the first term is 1. So we have to write cos x so that in such a way so that we have two portions. The first term will be, I'm saying two portions because we may not be having two separate terms. It may be an expression as well. So the first term should be 1. That is definite because it is 1 plus t. The first term should be 1 and then the second term is a variable t. So t can have any value or any expression. T can stand for some expression. That is valid. But 1 should be 1. So, and this is to the power of negative 1. That is easy because this can be written as cos x to the power of negative 1. This part is easy. But the difficult part is we have to write cos x in the form of 1 plus t. So let us try that. We don't have any other option but to write 1 as the first term. So I am writing 1 as the first term. Then there will be the plus sign. I am putting the plus sign. And since I have introduced a plus 1, I should be introducing a minus 1 as well. So it will be cos x minus 1 whole raised to the power of minus 1 because 1 plus cos x minus 1, 1 and minus 1, they will be cancelling each other and we will be having just a simple cos x. But because we have to use the binomial expansion, we have to have two portions. That is why I say two portions, not two terms, because cos x minus 1 is not a single term, it is an expression. But t is a variable, so t can be used for this cos x minus 1 part. Okay? And we know what is the expansion for 1 plus t to the power of negative 1. So in place of t, we will be writing cos x minus 1. Okay. So this is, and okay, first of all, before getting the terms, let me write what is cos x minus 1 equal to, because this is the cos x equal. Okay. So what is cos x minus 1? Let me take some other color. Can be better. Cos x minus 1 because we need cos x minus 1. We are subtracting minus 1 from both the sides. So cos x minus 1 will be minus x squared over 2 factorial plus x to the power of 4 over 4 factorial and so on. Okay. So in place of cos x minus 1, we have to write this expression. Okay. Go back to the same color. So now t is equal to cos x minus 1. And the expansion of 1 plus t to the power of whole raised to the power of negative 1, we start with 1. So we'll be starting with 1. And then minus t. So it will be minus cos x minus 1 plus t square. So it is cos x minus 1 whole square. Okay. And it will be dot dot dot. So now this is 1 minus, in place of cos x minus 1, we will be writing these two terms. We do not need more number of terms because we have to only take terms up to x to the power of 4. So we will be writing minus x square over 2 factorial is 2, so I am writing just 2 plus x to the power of 4 over 4 factorial and plus minus x square over 2 plus x to the power of 4 over 4 factorial whole square dot dot dot. Okay, so this is equal to 1 plus x squared over 2 minus x to the power of 4 over 4 factorial and plus minus x squared over 2 whole square is what? Is x to the power of 4 over 2 square is 4. Okay, and this is minus, this is plus, so the middle term will be minus 2 times x squared over 2 times x to the power of 4 over 4 factorial. Of course, we will not be taking this because it will be x to the power of 6 and plus x to the power of 4 whole square. So it is 4 times 2 is 8. So this should also get rejected, 4 factorial whole square and dot dot dot. So we do not need these two terms. We will be rejecting these two terms. This one and this one. Okay. So now we have to check 1 plus x squared over 2 is fine. You have to just check that what about the x to the power of 4 term equal. Okay. So this is equal to 1 plus x squared over 2 and 4 factorial is what? 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. Okay, so 4 factorial is 24. You can use the calculator as well because it is paper 2. You are allowed to use the calculator. X to the power of 4 over 24. So let me take I'm putting a plus sign over here and I'm taking the common denominator as 24. So this will be minus and this is 4 times 6 is 24. So this will be plus 6 x to the power of 4. Okay. So this is 1 plus x squared over 2. 6x to the power of 4 minus x to the power of 4 is 5x to the power of 4. So it is plus 5x to the power of 4 over 24. Okay. So we have got the same expression. I will be taking this one. Of course, it will not be ending over here, but up to x to the power of 4 we have taken. Shown. Okay. The part C, by using the Maclaurin series for arctan of x and the result from part B, the part B's result was this part. Of course, this doesn't end in these 3 terms, but we have taken up to x to the power of 4. Find limit x tends to 0, x times arctan of 2x over secant of x minus 1. And this is given in your formula booklet, of course. In case you don't remember, arctan of x, the expansion is again an infinite series. X minus x cubed over 3 plus x to the power of 5 over 5 minus and dot dot dot. Okay, so we have to just substitute, we have to put this expression in this limit expression, and we are having arctan of 2x is, and this is arctan of x. So wherever we are having x, we'll be writing 2x. Okay, so we start limit x tends to 0, x times arctan of 2x, so it should be 2x minus x cubed, so it is 2x whole cube over 3 plus 2x whole to the power of 5 over 5 and so on. Actually, this is appearing to be multiplied by 5. This is not actually multiplication, it is the power. So this is getting divided by secant of x. We will be taking these three terms because they have asked us to use the result from part B. So it is 1 plus x square over 2 plus 5x to the power of 4 over 24 and minus 1. Straight away these two can be cancelled. Okay. And this is limit x tends to 0. We are just multiplying the terms. X with 2x will be 2x squared. And this is 2 cube is 8, and x cube times x is x to the power of 4. So it is 8 x to the power of 4 over 3. There is this minus sign plus 2 to the power of 5 is 32. And x to the power of 5 times by x is x to the power of 6 divided by 5 dot 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 over these two have got cancelled, in fact. So it is just the two terms remaining. X square over 2 plus 5x to the power of 4 over 24. Okay. And the limit x is tending towards 0. So what we can do is the lowest power of x is x squared. So let us divide the numerator and the denominator by x squared. Okay. So this is limit x tends to 0. We are dividing both the numerator and the denominator by x squared. So it is 2 minus 8 over 3 x squared plus 32 over 5 x to the power of 4 minus dot 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 over half, because I'm dividing by x squared, and plus 5 over 24 times x to the power of 2. Okay. Now, since x is a very small number, almost equal to 0, therefore x squared will be even smaller. Okay, x to the power of 4, again smaller. So we can just ignore those terms, higher powers of x. So we are having 2 over half, which is equal to 4. This is our answer for subpart C. Okay. So we have completed answering question number 9. And I am Nilanjana Sanyal. I tutor IB Math, ASL and HL level students from within India and outside India. Of course, they are online tuitions. And I am starting my group online tuition for IB Math, ASL and HL level students for the fresh batches, the fresh students who have joined the grade 11. So if you are interested in joining my classes, if you want to know more about these classes, there will be small groups. And if you want to join my classes, you are seeing my email ID getting displayed, you are seeing my WhatsApp number getting displayed, you may contact me. Okay. And thank you for staying with me till the end. We meet again very soon in our next session, where we'll be solving question number 10 of the same paper. So till then, bye.